All right. So we just did some review at the beginning of class, and I'm going to start right here and say, if I have a sector of a circle that where this is 45 degrees and this is 8, you should be able to say, what's the area of that sector of this circle? And that would be 45 out of 360 times pi r squared. And r in this case is 8, so that would be 8 squared, so that would be 64, and there you go. Did anybody do with radians? Just curious. Cool. Okay, what did you do for radians then? Pi over 4 over 2 pi. You see why I have that in my top 20, a fraction over a fraction? Happens a lot in trig. This is one of the reasons. All right, so then that would be a flip and multiply. So this is over 1, right? So you flip and multiply, and that would become pi over 4 times, flip it, 1 over 2 pi. Those cancel, and it's 1/8. 1/8 of pi 64. And that 1/8 of pi 64 is 1/8 of 64 is 8, so 8 pi. Now, when you get confused about, like, wait a minute, that's an angle, and you were trying to find an area, pi is not an angle. Pi is a number. It is used in angles sometimes, but pi is 3.14. So do you get 8 times 3.14 is about 24, a little bit more, maybe 25? Does that make sense to you? Okay, so don't forget pi is a number. It's 3.14. Just because you see pi, and I know you're starting to get used to that as being radians, my area is not a radian. My area is a part of the circle. All right, so my final area there is 8 pi. And then what if you needed to find this little guy? That is called an arc length. That was the last one, and it's S equals theta r. Theta needs to be in radians. So theta is not 7 pi over 4. Why? Because then you'd be finding the arc that goes all the way around that part. This is the part of the fraction of the circle that we want. So again, it's just 45, which is in radians, pi over 4, times the radius, which is 8. That's 8 pi over 4, also known as 2 pi. Okay. Now I know that seems weird because it seems like an angle, but what did I just say about that? Pi is really 3.14, so that's really 6.28. If this is 8, then this would be 6.28. I'm rounding, of course. If you wanted an exact answer, 2 pi would be better. Okay, so there's a reminder of almost everything. Here's the last piece. Let's say this was a person that was running, and they ran around a big circle. There are neighborhoods that are in the shape of a circle. If you go to Google Maps, do you guys have that preloaded on your iPads? All right, take just a second, just because it'll be fun. Everybody go to Google Maps and type in Rotunda, Florida. I will see if I can get that to pull up on the screen. Pausing for a second here. All right, so here's Rotunda, Florida. Now, for those of you that travel to Florida from time to time, this is the big picture of Florida. So it's on the west coast of Florida, just south of Tampa. So in this area here, you may notice that there's some areas that are fully developed and have houses in them and stuff. And I'm going to change to a satellite view here. Just a second. Shrink that. Oh, there we go. Satellite view. And there were some areas that didn't get developed. Like right here, that's pretty clear. It's because there's a big river in there. There were other areas that didn't get developed. I'm sure the developer was thrilled to find out that there was a rare woodpecker that lived on this land. And so they said, sorry, you can't take the habitat for the rare woodpecker, so they can't build houses on that spot. So there was some spots that had that, but in the end, they obviously had a theme of a circle. All right, so if you were to run on this part of the circle, I can't draw on the map, unfortunately. Okay, I think you get the idea. There are neighborhoods that are made into circles. There's this rare time that I thought I could use that for real in an example. Okay, so back to my problem. If you were going to run on this, and this was 6.28 miles, okay, and you did it in 400. No, that's going to be too long. I'm going to try to make it like not you're not incredibly fast. 10-minute miles would be pretty easy. You did it in 70 minutes. Would you and your partner please figure out how many miles per hour you went? Pausing for a second. Okay, so I hope you started with a rate. 6.28 miles per 70 minutes. And that was not the one we wanted. We wanted miles per hour, so we just had to change one thing. You put minutes there just right away because you know you want them to cancel. What's a fact you know about minutes? 60 minutes is, try to focus please. 60 minutes is what? 1 hour, and therefore, yay, we've got miles per hour. So you should have done 6.28 times 60, all divided by 70. Raise your hand if you had that one right. How many miles per hour was that, by the way? So 5 miles an hour. That's reasonable jogging speed. You can super fast walk at like 4 miles an hour. So, okay. The average foot speed over uneven ground is 4 miles per hour. If you needed a reference, that's over uneven ground. That's not like a parking lot. The average foot speed for a convict who's escaping. Why would they need to know that? Because the guy got out. He broke out of the car right here. He's been running, and he's in the woods. How far could he have gone? They need to know the average foot speed over uneven ground is 4 miles an hour, and he's been gone for 4 hours. He could be 16 miles in any direction. Get the idea? Okay, so, all right. But we'll assume this was on pavement, so we were getting a little more than 4 miles per hour. All right, so that's up to today. So what's new for today? What's new for today is a lot of things. Pay attention. First off, have you noticed that sometimes sine was coming out negative? Like when we did this last problem here, did you notice that when we had those sides, one of them was negative, and then when we did the sine in that angle, since there was a negative side there, we ended up with a negative answer? Let's be specific again. If this was 45 degrees, then this was -1, and this was 1, and this was square root of 2. And so sine is opposite over hypotenuse, right? Do you get any time you are in this quadrant, no matter what the angle is, that side's always going to be negative. And when you do sine, you'll always have a negative sign down there. So instead of asking you to memorize in every quadrant what every function will be, we've got a snappy way to remember that. And it goes like this. All students take calc, A-S-T-C. And that is something you're going to write on your paper, I would bet you probably in the neighborhood of 100 times between now and the end of the semester. Because it helps you remember when I say, oh, by the way, for this next function, sine's going to be negative and tangent's going to be positive. You can use this to go, oh, so you must mean you're in quadrant 1 or 2 or 3 or 4. You'll be able to tell what quadrant you have to be in. So what do they stand for? Better write this down. All of them are positive in quadrant 1. In quadrant 2 over here, sine is, what do you think? Positive. Why is sine positive? Look, if you made the classic 45, 45, 90 here, and this is 1, 1, square root of 2, which of the sides would be negative? The side or the bottom? The bottom would be negative. Does sine even use that side? No, that's why sine will always be positive in the second quadrant, okay? And then tangent's positive here, and cosine's positive here. And if cosine's positive, then the other two are negative. If tangent's positive, then the other two are negative. You might be thinking, how is tangent positive down there? Both sides are negative. It's because both sides are negative. -1 and -1. And when you divide TOA, opposite over adjacent, you have two negatives. They cancel out. Tangent's positive down there. Okay, so you and your partner figure this one out. What's the right quadrant if tangent's negative and so is cosine? Don't say it. Talk to your partner. Tangent and cosine are both negative. Which quadrant must you be in? And hint, in case you forgot the quadrant numbers, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If both tangent and cosine are both negative. Tangent and cosine are both negative. What's your theory? What quadrant? Say it if you know it. Quadrant 2, very good. What if cosine and sine are both positive? Cosine and sine are both positive. If cosine and sine are both positive, you must be in quadrant 1. Very good. Okay, so how does a typical question today look then? Well, a typical question for today looks like this. Sine of some angle I don't know comes out to -1/2. Do you get that there's two possible places I could be? Which quadrants could I be in if sine is negative? Quadrants 3 or 4. Okay. So let's actually explore this one a little further. So everybody start with a nice clean circle with the XY axis and the ASTC. Remember me saying the other day that you should use your lasso and just like copy that because you're going to be pasting it, pasting it, pasting it. Do that, except use the ASTC thing. Because from now on, you're going to have to be able to know which functions are negative or positive in which quadrants. This is another one of the bajillion little things in circle trig that you have to know. None of them are incredibly hard, but in a typical question, you end up having to reference like 6 little facts you know about trig. All right, so if we're going to do the one I just said, sine of some angle is -1/2, the way I'd recommend doing it is crossing off the places that it can't be. And then drawing in a triangle where it can be. Well, it can be here. Now, I strongly recommend that you use an ambiguous angle like that one. Do you agree I could label that with 30 or 45 and you probably wouldn't argue too much? Whereas, if I had made my triangle really skinny like this, and then I try to call that 45, your eyes are going to argue with you. Like, that's not 45. These sides are definitely not equal. You know what I mean? So go with a short, fat triangle when you don't know what the angle is. Because then you could kind of argue that this could be a 45, 45, 90, or it could be a 30, 60, 90. Because it's going to be one of those two every time. Okay? So go with something a little more fat. This is an advanced tip. If you don't understand what I'm talking about, don't make a long, skinny triangle. Trust me. Okay, now I'm going to try to label its sides and angles. If sine is opposite over hypotenuse, and that's the key angle right there, then opposite's got to be -1, hypotenuse has to be 2, and then do you remember what this third side has to be? And therefore, what's the angle? And don't say 30. Because if it was 30, it would be up in quadrant 1. So it's clearly not 30. This is 30, but the actual place we are says it's not 30, it's what? You could say -pi/6, I would have accepted that, or positive 330. How many were thinking that? Good. And then what if we do a whole bunch of pi/6s? 6 pi over 6s would get you to here, so it's a whole bunch. It's not 12, though. It's 11 pi over 6. Your answer to this question is theta is 11 pi over 6. We always are going to give positive answers if given a choice, because positive answers are easier. And there's a reason, and you'll understand it more later. Right now, you're still learning this, so you give negative answers when you're doing inverse trig, but not so much when you're doing regular trig. Okay, so then some of you are remembering, but Mr. Server, you said there were 2 places where sine was negative. You're right. Did you notice that I completely ignored this spot at first? But there's another way I could do it. If this was 30, which is the reference angle, and this was negative 1, and this was 2, and this was the square root of 3, that would also give me this same situation, and therefore there's another angle that works. Would you talk with your partner and give me a positive answer and use radians? Don't say 180 plus 30 is 210 degrees. I don't want the degree answer. I want the radians answer. What's the other right answer? A bunch of pi over 6s. So, Dr. Partner, what do you think it is? She was gone yesterday, so I don't feel like it's fair to pick on her. I'll pick on you. 7 pi over 6 is correct, because it's 6 pi over 6 to get to here. A little bit further, 7 pi over 6. All right, awesome. That's a typical question. Now, the good news is I have taught you everything that you'd really have to know to be able to take the test. The test is not tomorrow, for sure. It's not even Monday, but it is Tuesday. Okay, so basically I would think of it as we kind of have new stuff tomorrow in theory, but it's mostly going to be a review. And then Monday's for sure review. And then Tuesday's the test. I know, that's quick. That's a very short chapter, but it is. It's a super short chapter. And let's actually look at some homework together so you can understand what I've gone over a lot of stuff really quick, but we spent a lot of time reviewing, so I'm feeling pretty good about where you're at, but, you know, yeah, I'm going to pause for a second while we pull up the homework. Okay, so here's the first page. We're going to do just pages 1 and 2. And these are the problems that are more like what we were just working on. I know those are going to be tough. These should be easy for you. You're supposed to find the sine and the cosine of each of these angles. Now, my advice is to draw circles and figure out where the triangle is and label its sides and angles. And then this page shouldn't be that bad. This page will definitely be tougher for you, but give it a shot, and that's my only assignment for tonight. Have a great day.